Good day, everyone, and welcome to the Women in Data Science Trinidad and Tobago Datathon 2025 workshop series. I am Dr. Leticia Addison, the WiDS TT, as we call it for short, ambassador. And in today's session, we are doing a follow-up from our first workshop last Saturday, where we spoke about getting started with the Datathon. In today's session, we are going to look at an introduction to data models and data stories. So let's get started. First of all, for persons who may be new, just to remind you about what WiDS does in terms of the Global Organization for Women in Data Science, we celebrate, inspire, educate, and support through extensive programming and workshops worldwide and also regionally. These take the form of conferences, datathons, which are data challenges for data enthusiasts to jump into, podcasts, WiDS Next Gen for educational outreach in secondary schools, and also monthly workshops globally. For those of you who may not be aware, WiDS actually started as a conference, a one-day conference in Stanford University in 2015, and it has grown tremendously throughout the years with more than 200 regional events and more than 120,000 participants worldwide. So it's very, very exciting. And in Trinidad and Tobago, we are happy to be part of this cohort. So every year there is a data challenge, what we call a datathon. And for the past few years, we have been doing social impact challenges. In this year's Global Datathon Challenge, we look at brain health, and the theme is unraveling the mysteries of the female brain, which is looking at how neurological diseases and also aspects of ADHD and other parts of the human anatomy and human interactions, how those are studied, particularly in females. So the datathon itself runs from January to April. And for those of you who would like to hear more about it, you can click on the link. As you see on the screen, we will send you some of these links as well in the chat, so you can learn more about this Global Datathon and sign up for it. Now, in terms of the actual datathon and the data challenge, I know some of you probably may or may not enter the challenge itself, but you actually want to understand how to use data science. That's okay. Those of you who would like to jump into the challenge, we have various workshops, not only from Trinidad and Tobago, from various countries. Ambassadors around the world are hosting workshops. So these events are meant to bring together persons who would like to participate in a datathon as well. And for those of you who are interested, just giving you some quick tips that there will be team building sessions. So for instance, in terms of the teams that you can form, it's 1 to 4 persons, and at least half of them should be identifying as females. And of course, through this process, over the months of January to April, you would have access to mentors, workshops, and other events. And of course, there would be some cash prizes in terms of the actual global datathon itself. And some of the local groups would also organize prizes for participants also. Now, networking is really important. So as you see, it's more than a competition. In this particular case, we are actually connecting everyone with persons around the world to work for a common cause. So in terms of data science, within the Women in Data Science Trinidad and Tobago WiDS TT space, we host these workshops and regional events as well. Some of you would have been in our workshop 1 and our past workshops. We started in 2022, and we have been hosting workshops both online and in person for the past 3 years. The events are open to all, even though you hear it's Women in Data Science. We do represent the women and underrepresented groups, but we cater to all audiences, and males and females are welcome. widstt.com is our website. So for more information on these events, you can also jump in there and see some of our past events and also visit some of our resource links. So for those of you who want to know what upcoming events we have a fireside chat that's happening on March 8th. So that will be our next event with some persons in the field, specific women in the field, both locally and also internationally. So you can visit our website. We will have that posted within the next few days, but the link is on the screen and we will also put it in our community. So you can also be a part of that. And just a reminder, this is probably the best summary of information you can have for the different links that you will need. As I said, don't worry, you'll get all the links that you would need to actually access the challenge. For those of you who are already aware, Kaggle is the place that the challenge takes place. So you would want to sign up for a Kaggle account if you haven't already. And there you'll be able to view the actual Datathon challenge, as we mentioned last week. You also can register for the challenge itself on the WiDS conference page, the WiDS worldwide page, to show that you're a part of the global cohort that's taking part in the challenge. Now, in terms of WiDS Trinidad and Tobago, we also have teams who participate. And if you would like to be part of our teams, in March, we will actually have some onboarding sessions for persons who would be interested. So you can also visit widstt.com and fill out our call for participation form. If you have any questions, however, regarding any part of the process, any of our events, feel free to contact us via widsttgroup@gmail.com, and we would be happy to answer your questions. Now, this is something fairly new here I'm mentioning. Some of you would probably have connected with us through the community platform, and this is a really wonderful new addition that the WiDS worldwide space has created for different WiDS teams across the world. So we are here, and for those of you who want to join the community platform and get more real-time information about our events, feel free. Also note that we are on different social media platforms as well if you'd like to follow us. So we are on YouTube, and we also have a playlist that caters to different persons from beginners, intermediate, advanced. So you can click on our different playlists and videos from our past Datathon events. And you can visit our website widstt.com/resources, and you'll be able to navigate to those resources to see which ones interest you. So we would really encourage you to make use of all these resources. Our mentors put a lot of time and effort into creating these to help you on your journey. So we'd be happy for you to access these. So the main event and the reason why you are here today is for our workshop 2, which is our basic introduction to the data models and data stories. Just to let you know, because it's a 2-hour time span, in some cases, you may find that certain aspects may probably go a little bit faster. If you would like to slow it down and ask the mentors for that sort of support, that is also free and available to you. And of course, after the workshop, if you need further support, especially in case of people who may be absolute beginners and would like to get some more information regarding some of that material, you can reach out to us as well. Do note that we will post the recording on YouTube, as I mentioned previously, so that you will have the access to the recording to be able to refer to. So today's workshop, we have our workshop team. I'm very, very proud of my mentor team who is here today to present to you this material. I will give each of them in a little bit of an introduction. They can introduce and let you know about their background and how they will assist you today. So this team includes Miss Julie Kun, Miss Malini Rambaran, Miss Leslie Ann Jurawan, and also Mr. Nicholas Smith. We also have male mentors on our team who help our participants. And if you would like more information about each of them in a more detailed way, you can visit our website and see their bios. So I will stop sharing at this point, and I will pass the floor on to our first mentor, so Miss Julie Kun. She'll give you a bit of her background, and then we'll go through to each of them. Not too sure if Nicholas is here today, but he's here in spirit. So Julie, you can take the floor.
Hi, good morning, everyone. Just a little bit about myself. My name is Julie Kun. I'll be one of the presenters for the WIDS workshop today, with workshop number 2. A little bit about myself, my educational background. I have a bachelor's in computer science and management, a master's in data science, and I'm currently finishing up my MBA with a specialization in business analytics. Beside my educational background, I currently work as a data scientist at one of the Caribbean's largest financial institutions. I am also a part-time lecturer for the program offered by SPCS, which is the Bachelor's in Computing for the University of Greenwich. I'm also a researcher, part-time researcher, just as many of the other presenters for TT Lab. And TT Lab it pioneers research in the Caribbean and developing new and exploring new things. Yeah. Yeah, so I will pass you on to Malini.
Thank you, Julie. Hi, some of you may have remembered me from Workshop 1, but for those of you joining us today for the first time, I'm Malini Rambaran with a Bachelor's in Computer Science, Master's in Data Science. I've been a WES mentor since last year, contributing to Workshop, and also I would have co-developed a data detective challenge with my fellow WIS mentor, Nicholas Smith, for a bootcamp that we held last year. I'm also part of TT Lab as a researcher, just as my colleague Julie, and I'm excited to be here today presenting part two of the storytelling component, and I look forward to diving into the session with all of you. So I will now pass you on to Leslie Ann.
Hi, everyone. I'm Leslie Ann Gerawan. You might remember me from such times as last week. In Workshop 1. And I'm a WIDS volunteer and contributor as well. I really love finding ways to make data more accessible to everyone. So being part of this workshop is a really great opportunity for me. And my path to data science started in mathematical science, went to business. I got my master's in small medium enterprise management long after getting my first degree in mathematical science in University of Waterloo. And since then, I worked in the education sector as well as the cocoa and chocolate sector. And through data analysis, I found machine learning and my way to data science. So I'm really happy to hear about stories, unique stories and pathways into data science. So drop me a line anytime, and I'm really happy to take part in the workshop with you today. Thanks.
So you all can get started. So we'll pass it back to Julie.
All right, so I'm just gonna take off my webcam so it doesn't affect the slides presentation quality. All right, and you guys can confirm for me that you are seeing the slides on the screen.
Yes, we are.
Yeah, okay. Making sure. Right, great. All right, so just a recap of last week's session. So last week's session we would have loaded and explored the data set. We did a walkthrough of the data fields. Reference was made to the data dictionary, and the quality of the data was assessed, and a thorough exploratory data analysis was done. The presenters, Milady, would have also covered univariate and multivariate analysis, and you can just review those in the notebook. So those would have been sections 1 to 4. Right, so today's presentation will cover an introduction to data models and data stories based on the dataset from Kaggle 2025 WIDS competition. Right, so in today's session, we'll cover the following 3 topics. So we may not always go as planned here. However, we'll try to keep it as close to this as possible. Right, so the first session will cover feature selection. The second session will cover an introduction to modeling. The third session would also cover data storytelling. And then lastly, we have a Q&A. However, if you have questions throughout the presentation, you can always send a message in your chat and someone can respond. Yeah. So let's get started. What is feature selection? So feature selection is the process of identifying and selecting the most relevant features in a dataset that contribute significantly to the predictive power of a model. So this step reduces the dimensionality of the data set, which can improve model performance, reduce computational cost, and prevent overfitting. So we'll discuss what overfitting is in the following slides. Effective feature selection ensures that the model learns from meaningful data rather than noise. And so from the image you see on the screen, we saw that only a subset of features were selected for the final stage. You're seeing that? So initially we started with these features, and at the end of our feature selection, we had these features here. Right, so let's discuss the purpose of feature selection. So why are we doing feature selection? So the primary purpose of feature selection is to remove irrelevant or redundant features that do not contribute significantly to our target variable. So in this case, our target variable is the gender and if the person had ADHD. And this leads to, feature selection leads to a more efficient and interpretable model. By reducing the number of features, models become faster, easier to train, and less prone to overfitting, which is especially crucial in data science competitions. So we'll discuss the difference between overfitting and underfitting and why we don't want those for our model. So overfitting happens when a model learns too much from the training data, including details that don't matter, like noise and outliers. So as we see here for the overfitting model, that is a green line. Yeah, so for example, just giving you a real life example, imagine fitting a complicated curve to a set of points. This is what we see here. So the curve will go through every point, but it won't represent the actual pattern. So as a result, the model will work great on training data, but it will fail when tested on new data. For an even more real example, overfitting models are like students who memorize answers instead of actually understanding the topic. So they do extremely well in practice tests. We'll call that our training, but they struggle in real exams, and that is where we have our testing, right? Just making sure you all understand. So let's take a look at underfitting. So underfitting is the opposite of overfitting. It happens when a model is too simple to capture what's going on in the data. For example, imagine drawing a line to fit points that actually follow a curve. So the line misses most of the pattern. So in this case, the model doesn't work well on either the training or testing data. Underfitting models for real life example would be like students who don't study enough. So they do well in practice tests or real exams. Yeah, and some reasons for underfitting or overfitting. So for underfitting, the model could be too simple, right? So it may not be capable of representing the complexities in the data. Right, and here we have a comparison of overfitting and underfitting. Right, so we see this is an underfitting model. The ideal would have been following the curve as seen in this image here. And then here we have an example of an overfitted model where we train on every single data point. All right, so let's take a look at some feature selection techniques. So for the purpose of this, we won't go too in depth into all of these. However, there's a link here that you can click on and you can get more information about it. All right, so some feature selection techniques, as we see here, feature selection techniques can be broken into two types. We have supervised and unsupervised feature selection techniques. So we have filter-based approach. So these techniques evaluate the relevance of features using statistical methods before training the model. We have wrapper methods. So these involve iteratively selecting or removing features based on model performance. We have embedded approach. So machine learning models select important features internally, and feature importance could be selected using models such as random forests. And then we have some unsupervised techniques like principal component analysis. All right, so we won't go too in depth into this due to time constraints. However, we have the link here. All right, so let's take a look at our Google Colab book. All right, so we're going into section 5 of the Google Colab book. You can just confirm with me if you're seeing it on the screen.
Yep, seeing it.
All right, wonderful. All right, so in last week's workshop, workshop 1, these first 4 topics were covered. So they imported the data set, they loaded it in, they inspected and merged the different data sets for analysis. We also assessed the data quality and initial exploration, as well as performed some EDA, which involved univariate analysis and bivariate, as well as multivariate analysis. Right, so we're continuing 5, so feature selection. So what it involves, I'll leave this to you to read up, and why it's essential, and some points to note on feature selection. And there's also a link here to find out some more on it. But the first thing we want to do is discuss handling missing values. So here we impute the missing numerical values using the median. But why did we use the median? So unlike the mean, the median is less sensitive to extreme values, making it a better choice when the data contains outliers, right? And it preserves the actual distribution of our data set. So the median maintains the central tendency of skewed data, preventing distortion in the data set. All right, so we have an example. So if a numerical column has a right skewed distribution, for example, income data, using the mean could inflate the values, while using the median provides a more stable replacement. Yeah, and where would we use this? Why is it important to handle the missing values now? While the data set with the imputed values will be used for our model training and for cross-validation, right? And if we did not impute this data or fill our null values, our model would have failed due to it having null values, yeah? So here, this is where we filled our missing values. And we saw that we identified 360 records were missing from MRI track agent scan, and 11 records were missing from pre-int demos farm child ethnicity. Our next step in our feature selection was identifying our highly correlated features. So in the previous analysis done in workshop 1, a correlation matrix was done, which also visually displayed our features that were highly correlated. So why did we do this? Highly correlated features contain redundant information, which adds noise and can make models less interpretable. So our solution for this would be to identify features with correlations of above 0.85, and this will help us to decide which variables to remove. And why did we use this? Why did we do this and where did we see it later? So we use feature selection to reduce the data set dimensionality before training models like random forest, gradient boosting, and logistic regression. So we will discuss statistical models a little later on. So this is our code here, and we identified our highly correlated features. Again, if you scroll up in your notebook, you'll see the correlation matrix done in workshop 1. Right, so these are the features here that we would have identified as highly correlated. So our next step was to select important features using random forests. And why did we do this? So our data set had many variables, but not all were useful for predicting ADHD or sex. So our solution, we trained the random forest classifier to rank feature importance, and then we selected the top 15 features. And where did we use this later? We used this later when we had our model training and our cross-validation. Right, so this is the code here. But we would have selected the feature importance, right? And we see our selected features here at the bottom. We're seeing it listed out. Right, so I'm just going to go back to the slide. So we'll discuss a little bit about statistical modeling before we get into the notebook itself. Right, so we're looking at statistical modeling. So what is statistical modeling? Statistical modeling is the technique of applying.
Before
Sorry?
you go on, right? You just wanna explain. Someone was asking about, just for the benefit of everybody, how to determine if our model is moving towards over or under fitting. So I don't know if you wanted to just go back to that and just kind of show them the graphic. Just in
Sure.
case.
Yeah, let me get that up. So in the previous lecture, which was done by Malini, she discussed when she did the multivariate analysis, how we knew that our feature was overfitted versus underfitted based on our correlation matrix. So we saw here how many features we had, and due to us having so many features, I mean, I know it's a bit much to see on the screen. This is kind of what would have determined to us that it was overfitted or underfitted.
And what you also want, I'll add to what Julie is saying, is when she's doing the modeling process, when you have the training and the testing data, which Malini would have mentioned last week, your model, if it's overfitting, it means it does very well on the training data. But on the new data, which is your test data, it performs poorly. So you're overfitting the model. And in the other way around, the underfitting is that it struggles with both the training and the test data. So it's not really a perfect fit for the actual model. And when you do any statistical models as well, sometimes when you do the graphical, if you look, try to create a scatter plot or a graph, and some of these models you can actually, in the software, you could create a line of best fit, a QQ plot, PP plot, and these things that could kind of give you a guide. So all of these are just examples, right? So when Julie goes through more of the modeling process, she'll kind of hint at how you could look at the data and kind of tell. Michaela is also asking, why did we choose the random forest technique for feature selection over other techniques?
So there was no specific reason for using the random forest. I just preferred using the random forest due to experience working with the different models, and that is why we would have used it. Also, it was one of the simpler models to use for today's presentation. But you could have used any model you wanted and looked at the output and see for yourself. Yeah. Let me check the chat.
Any
Yeah,
more
so
questions?
the when we did this, I know it seems like, everything is already kind of known and it's done up. We would have done multiple iterations to choose models and to choose why we did what we did. And I know it's not being shown here on the screen, but that would have made the workshop much complex because we would have been iteratively going back and forth and fixing the model. Yeah, so to kind of keep it with a flow, we would have already chosen models that worked best. I'm not sure if that answers the question as well.
Just to add what Julie's saying there, when you are actually doing this from scratch, you would probably experiment with various models. So you'll be in more of an experimental phase, and then you can test and see which one performs best, right? Okay, great. Okay, I think Julie, you could continue. If anybody else has questions in the chat, we'll take them.
So I don't know if I had a slide before. Let me go back. Okay, I just want to make sure I didn't miss anything. All right, so statistical modeling. So what is statistical modeling? Statistical modeling is the technique of applying statistical analysis to a data set. And this data set is, so that's basically is we apply some statistical analysis to a data set. So the statistical model itself is a mathematical representation of observable data or even just a mathematical model. And the goal of our statistical modeling is to gather sample data and make predictions about the real world. So basically, it enables data scientists to see correlations between random variables and analyze information strategically. So I'll give you a further breakdown. So let's say we wanted to know if the person's income had any effect, or not only just the person's income, but let's say I don't want to use our target variables. So let's say the person's income and their family status quo. We wanted to see if those variables, we would have used a statistical model to see if there was any correlation between those. Yeah, so let's look at the components of a statistical model. So a statistical model consists of variables, parameters, and equations. So variables are the elements that can change or take on different values within a model. Variables can be independent, so predictors, or dependent outcomes. And it also consists of parameters. And parameters are constants in the model that quantify the relationship between variables. They are often estimated from the data. So think of we also have mathematical expressions, and these describe the relationship between the variables. So think of the very first model you would have probably seen. So I know for Caribbean students, it would have been at CXC math level where you looked at the y equals mx plus c. So this is actually an example of a linear regression model and in its simplest form. Yeah, so we have types of statistical models. So here we see statistical models can be broken into supervised and unsupervised. And we have regression, we have classification, undersupervised. And under unsupervised, we have cluster analysis, factor analysis, principal component analysis, and many others. All right, so we're just taking a look at a few. So we have linear regression, and linear regression predicts the relationship between a dependent variable and one or more independent variable. So it assumes a linear relationship between the variables and is often used for forecasting and estimating future trends. So we have an example here of a linear regression graph. It looks a bit familiar, with the y equals mx plus c, the equation of a straight line. Yeah. And then we have logistic regression shown on the screen. And logistic regression is a binary classification model that predicts the probability of an event occurring or not. So it's widely used in healthcare, finance, marketing to predict outcomes such as whether a patient will develop a disease or whether a customer will buy a product. So basically, it kind of gives you a yes or no outcome. Wait, so let me just go back to the image so you can see that. Yeah, so this is our logistic regression here. Okay, so we have some more statistical models. So these are the last two that we will be covering. We have decision trees, and decision trees are visual representation of a set of rules that lead to a decision. They are often used in machine learning and data mining to predict outcomes and classify data. So for example, here, if you have your salaries between this, yes, office near to home, no, decline offer, and so on. And this helps you make a decision. Yeah, I think decision tree is probably one of the most common ones. We also have random forests. A random forest is an ensemble learning technique that uses multiple decision trees to make predictions. It is often used in data mining and machine learning for classification and regression tasks. So we see here we have multiple decision trees, decision tree 1, decision tree 2, and so on. And we use this to get our final result. So we're going to take a look at the notebook now, where we cover statistical modeling, and we actually used different models. Yeah, I'm just going to change screen. All right, so can everyone confirm they see in the notebook?
Yep, looks good.
All right, great. Glad you all can see it. So a machine learning model is a mathematical model. After being trained on a data set, it can make predictions or classifications on new data by identifying patterns within the information. So in terms of our challenge, the datathon, the thing that we want to predict is the gender and the diagnosis. And both of these are classification problems, meaning that the outputs would be binary. So it's either 1 or 0 for male or female, or 1 or 0 for having HD or not having HD. So to predict both target variables simultaneously, we will use a multi-outcome machine learning model. Right, so this type of model is designed to predict multiple dependent variables or outcomes at the same time rather than one at a time. Right, and we would have trained our different dataset based on the columns gender and ADHD. And why do we want to use a multi-outcome model? So this approach is particularly relevant to our specific challenge of investigating ADHD diagnosis in women. Right? And research suggests that women with ADHD are often underdiagnosed, and by modeling gender and ADHD diagnosis together, we can explore potential relationships between these variables. So the first thing we wanted to do was handle imbalanced data. So I know this topic is a kind of tough one, but there are I think there's some links within the notebook to kind of assist with this. So our data set here, we have the ADHD outcome binary with a yes or no. We also have the sex of the person, so whether it's male or female. And we noticed that this data was imbalanced. And I'll just ask you a question. Does anybody know what imbalanced data refers to? Anyone? Without Googling? All right, so we will discuss imbalanced data. So basically, when we say that this data set was imbalanced, we saw that, well, Malini would have covered this in the previous workshop, but we saw that we had more cases of either having ADHD or not having ADHD. So it was not equating to the same values. For example, we would have had like 1,000 persons with ADHD versus like 2 persons not having it. You get how the data can be seen as imbalanced there? I mean, those aren't the actual figures, but that's just a reference to help you understand. So to handle imbalanced data, we would have used a technique called SMOTE, right? And SMOTE stands for Synthetic Minority Oversampling Technique. So since the ADHD outcome is imbalanced, using a traditional model without addressing this imbalanced data could lead to biased predictions where the model favors the minority class, no ADHD. So to counter this, we applied SMOTE, which generates synthetic minority class examples rather than duplicating existing ones, helping to prevent overfitting, right? This also balances the class distribution, improving model fairness and accuracy. It also ensures the classifier does not ignore the ADHD positive cases, which increases sensitivity or recall. So we will see what this means when we look at model evaluation. So how did we apply SMOTE to our data set? So SMOTE was applied only to the ADHD outcome since it does not support multi-output targets, right? When I say multi-output targets, it can't support looking at both ADHD and the gender at the same time, right? So the sex feature remained unchanged to preserve its original distribution. So after resampling, we reassigned genders values by randomly sampling from the original data to maintain alignment with the new data set. So let's see what this means, right? So here we reset the index before applying SMOTE. We reset the index just to handle coding errors, not to say like, anything too intense here with that. Then we applied SMOTE to our model, and we created a new data frame called Y-balance. We also reset the index after SMOTE, and then we assign the sex by randomly sampling from the original distribution. And then to confirm that we fixed our errors, we print out the outcome. So the new class distribution. So in the case of ADHD, we say that our new class distribution, we had 831 persons having ADHD versus 831 persons not having ADHD. So we fixed the issue of imbalance with regards to this particular variable. However, for sex, we have 0 at 1,075 versus 1 at 587. So we have less females than males. Yeah, so we still have some level of imbalanced data, right? So you guys could run this exact same code against this for this gender, right? So we left something for you guys to do. So this is just a breakdown of the code if you want to understand it more and how it works. So the next step was splitting the data for training and testing. So for any machine learning model, you need an X-trained data set, which contains the feature variables used to make predictions about our target variables. In this case, our target variables are ADHD and gender. So our feature variables include categorical columns, quantitative variables, and functional connector matrices. So we have prepared our X-trained data frame by encoding categorical variables, merging data frames, and handling missing values. So some of this, well, most of this was covered in last week's workshop, right? So in addition to X-train, we also needed a Y-train. So the data set containing the target variables to train the model. Right, so the target variables allow the model to learn the patterns in the feature variables that lead to specific outcomes for ADHD diagnosis and gender. And this relationship is what enables the model to make accurate predictions when applied to new data. So here we apply that, we used our balance data now that we created using SMOT. Then we split our data set into our training and test, right? So our test size is 20%, and that means our training size was 80%, right? And then we displayed the distribution of the different outcomes in the training and test, right? So here we see train ADHD outcome distribution. We had this value here. We see it looks pretty good. It looks pretty balanced, right? We also have this here for the ADHD outcome distribution again. So this is the test. So we saw that the train and the test performed well, yeah, based on the values that we're seeing. And then in terms of gender here, we're seeing it's not really equal. So let's discuss what this results mean, right? So what does this mean in terms of the ADHD outcome results? So the ADHD outcome was originally imbalanced, but SMOT successfully balanced the classes before splitting. Training and test distributions are very, very close. As we see here, it's like a 50-50, almost 50-50. And that ensures that we have a fair model evaluation. Stratification worked correctly, and it preserved the ADHD class proportions, right? So there's no bias here because we don't have any imbalanced classes. With regards to gender, so the sex F feature remains imbalanced. We see that we have more males than females. We see that here, more males than females. Test set has fewer females than the training. So we have a slight distribution shift. Stratification was only applied to ADHD outcome, not gender, so its natural imbalance remained. And some potential issues, the model may be biased towards predicting the minority class, so that is males. And a solution to resolve this could be consider balancing sex F using SMOT or weighing classes during training, right? So you basically would run the exact same code and just kind of change it towards this variable, right? Sex F. Right, so the next thing we looked at was training a multi-outcome model. So here we simply train the model using these statistical models. Say so random forest, gradient boosting, XG boosting, cat boost, and logistic regression. We only covered a few of these due to time constraints. So you import your functions here, and we have a variable called models where we stored our different models in it. And we applied our model predictions, right? And then we printed our results. So here we have a lot of results. In the PowerPoint, I would have collated the results of this outcome, right? So I guess you guys could see it more openly in the Excel sheet. So I'll just, sorry, not the Excel sheet, the PowerPoint. So let me just switch to that for you. Oh, okay. I'm going back to I'm actually going back to this book. So we had the sample predictions, but before I get into that, we would have discussed the model evaluations and how we knew the model performed based on our model evaluation techniques, right? So I'm just going to go into model evaluation techniques, and then we'll discuss the significance of our results. Yeah, so we'll evaluate the performance of our model first, and then decide which model we went with, just to make sure everyone is followed. So model evaluation techniques. So evaluation is always good in any field. So how will we know that what we did was accurate or it was good? How do we know that we can continue doing what we did? So in the case of machine learning, it is a best practice to evaluate your models. And in the case of the notebook that we're working on, we used precision, recall, and F1 score. So precision, the definition of this is out of all positive predictions, how many were actually correct? And why is it important? It helps when false positives are costly. Example, misdiagnosing ADHD. So let's say we predicting somebody had ADHD. How many of those predictions were actually correct? And we use precision to give us that value. Right? We also had recall or sensitivity, and this refers to out of all actual positive cases, how many were correctly identified, right? And this helps when false negatives are costly, right? So missing ADHD cases. For example, we said somebody did not have ADHD, and it turns out that they had ADHD. That would have been something very serious, right? We also have F1 score, and this is the balance between precision and recall, and this is the formula for it. And this is useful when classes are imbalanced as it combines both precision and recall. Right, so this is how you go about calculating the different formulas. So for accuracy, we have correct divided by the correct and the incorrect, and precision and so on. So we won't go too much into this. I'm gonna go to the notebook now, where we look at applying these model evaluation techniques to our model. Right, so why did we use these metrics, right? So we discussed what these metrics meant, the definition of them, and how we calculated them. So for ADHD classification, recall is crucial because we don't want to miss any true ADHD cases. The F1 score is important because since the dataset was originally imbalanced, the F1 score helps balance precision and recall. And for sex classification, precision matters. Since males dominate the dataset, we need to ensure females aren't misclassified. And for F1 score, it helps to detect bias. So if one class has a low recall, the F1 score will reflect that. All right, so here we applied our different models, our different evaluation techniques to our model. Right, so all of this is kind of built in Python, so it kind of saves us the task of having to code the formulas ourselves. Right, so this loop here would loop through each of our model's predictions, and it would generate an evaluation report, right? And the evaluation report is what we will analyze and then make a decision on to know which model we thought performed the best. Right, so just taking a look at it here. So with the random forest evaluation model, we had ADHD diagnosis classification report. We had the precision for having ADHD versus not having ADHD. We had the recall values, we had the F1 scores, and we had the support. So generally these figures are fairly high. So this is a good thing. So this tells us, okay, random forests perform not so bad in terms of ADHD diagnosis. And for sex classification, we see in lower figures. We see in here for precision, it had like 0.67. We saw for males, that is. For females, we saw 0.39. We had high recalls. We had a fairly okay F1 score. And the same for gradient boosting, right? So we had more or less high scores for ADHD. And is when we looked at gender, we kind of had lower scores, right? And that is because of the imbalanced data there. Right, so I'm gonna show you this collated, and then you guys can tell me which model you think performed the best. Right? So taking a look at the data you see in here on the screen, or the results of our different model evaluations, which model do you think performed the best for ADHD diagnosis? Okay, I'm seeing someone send random forest. Anybody else? Let's take a look at the data. So I'll give you all some time to look at the data and tell me which one you think is the Okay, someone said cat booth. Nice. All right, so I'm seeing two persons saying cat booth. So I'll just give you just a minute and then we'll discuss the answers. All right, so let's look at the answer. And the answer is random forest. So Sana, you were correct. So the best model for ADHD was the random forest because it had the highest F1 score and the highest recall score. So most balanced performance across all the other metrics, right? If we look at the results, it performed the higher, it had the higher values for this. So it had the highest recall for class 0, where ADHD was not diagnosed, and it had a strong precision for class 1, where ADHD was diagnosed. We had low false negatives, fewer missed ADHD cases. And the model that performed the worst, but it didn't really perform bad, was the logistic regression, right? So it just had a little slightly lower values, right? It had the lowest recall and lowest accuracy. So it performs significantly worse than the random forest and boosting models, and it more or less misses more ADHD cases and lower recall. And this is with regards to the ADHD diagnosis. So now we're going to take a look at the results of the gender diagnosis. Right, so let's take a look at our results here. This one is a bit tricky, right? Because remember, we're taking into account all of our metrics, right? So all of our evaluation techniques here. So looking at the results, which model performed the best for sex classification? Okay, so I'm seeing one person said XT boost. Anybody else? Right, I'm seeing Videsh sent uh some notes for you on model evaluation, so you can check those out because I know we didn't go too in-depth into it. Yeah. Somebody said logistic regression. Okay, nice. I'm liking what I'm seeing. Anybody else? All right, so let's take a look at the answer. So the best model was actually the random forest, right? So the biggest issue here is that the sex classification performance is poor across all models, right? And that is because the data itself was imbalanced, right? So you guys made great attempts, really great attempts, right? So all models struggle with identifying females, right? So it's very low recall for females. The logistic regression completely fails at predicting females because we see the values here. It outright just gave up here. And best recall for females is still only 0.29, right? We see in that the 0.29 with the XG boost, meaning that 71% of the females were misclassified. So from the XG boost here, we see that 0.29, that was the highest we got in terms of this. And why did we choose random forest as our best model? So it had an F1 score of 77, so 0.77. So it had the highest recall for males, which is 88%, and it had better precision than all the other models. However, it still fails to predict females accurately. So while this performed the best here, to have our model actually perform better, we need to perform some cross-validation on this, or even just simply balance the data, right? Balance that gender data. So, oh, I didn't ask you guys, but basically it's a kind of obvious answer, but which model performed the best overall? Right, so the model that performed the best overall was Random Forest. It had strong ADHD classification, and out of the results we saw, it had the best sex female performance, right? Okay. So the sex classification is a major issue. All models fail to correctly predict females. We could have fixed the model prior if we perform SMOT or some kind of way to balance the gender column. And we could also look at more techniques that we could have used to address this, right? And logistic regression is the worst model because it performed poorly in both the ADHD and the gender prediction. So now let's take a look at cross-validation, right? So given that we're kind of going good with time, I think we can discuss it. Just want to confirm, Dr. Addison, that we're going good with time and we can cover cross-validation.
Oh, yes, yes.
Yeah, all
You
right,
can go
great.
ahead. Yeah.
Yeah. So what is cross-validation, right? Cross-validation is a technique used in machine learning to evaluate the performance of a model on unseen data, right? So it involves dividing the available data into multiple folds, right? So we see four-fold validation here. So dividing the data into multiple folds or subsets using one of these folds as a validation set and training the model on the remaining folds, right? So this process is repeated multiple times, each time using a different fold as a validation set. We see that? So here in this first instance, this first fold was our testing set. Then here, and the rest of the data was our training set. In terms of the second fold here, this was our testing set, whilst the rest of the data was our training set, and so on. So the process is repeated multiple times, each time using a different fold as the validation set. And finally, the results from each validation step are averaged to produce a more robust estimate of the model's performance. So cross-validation is an important step in the machine learning process, and it helps to ensure that the model selected for deployment is robust and it generalizes well to new data. So let's take a look at our notebook where we discuss cross-validation and how we applied it to our data set. Right, so the cross-validation score is a metric used to evaluate the performance of a machine learning model by testing it on multiple subsets of the data. It provides an estimate of how well the model is likely to generalize the unseen data. And how it works, well, we discussed that in the slides where we take a fold K, right? We split the entire data set into different subsets, and then we keep training and testing on each subset. Yeah, so the evaluation metric we used was accuracy, and it was computed for each iteration. So why did we use cross-validation? So it ensures that the model is evaluated on multiple subsets of the data. Right, so we just applied it on just 3 of the models. So we used the random forest, the gradient boosting, and logistic regression here. So we defined the models that we were using here. So we applied cross-validation for each model and each target separately. So here we did the ADHD outcome. Here we did the sex classification, cross-validation. Right, and then we saved our results and then we outputted these results. So these are the results of our cross-validation. Yeah, and looking at this, which one do we think would have performed or had the better results from the cross-validation? Did we choose the right model? No, so it's not a replacement. So we did still divide our model into that 80-20 where we tested and training. This is an additional step to make sure we have an accurate model. When I say accurate, a best performing model. Right, so the entire process is iterative. So if it is you reach to this end and you see a model is still not performing well, you go back over to the top and then you do more analysis on it, on your data throughout. I hope I answered the question correctly. Yeah, Michaela? Okay. Yeah. So looking at our results here, we actually did pick our best model because we are seeing random forest had the highest values as seen here. And in our data storytelling for our statistical modeling, in that presentation, we will also be discussing how we presented the data for random forest. I'm seeing a screenshot in the chat. I cannot view it for some reason. Give me 1 second. Let me see. Okay, right. So these are the results you saved here. Yes. Okay. Oh, you're saying your numbers are different. Yes, so the numbers won't be the same because remember, this is a new set of sample it will be taken, so it'll be new different values you'll get back. So that's fine. That's totally fine. The values will be roughly the same, just a little variation and just like a small decimal off or something like that. It won't be too significantly different. Yeah, so no problem there. And so I'm just gonna go back to these slides, right? So the last thing we want to look at is our solution submission. So we've built our wonderful model, but what do we do with that model? Right? So here we have a section creating a submission file for the WiDS Datathon 2025. So we have our model that we created from before. So we used our model here, random forest. If you wanted to use a different one because you had different results, you could have done that. So we apply the model to our unseen data, which is what we want to predict for. Right, and then this would have given us, well, this entire code here. So we prepare the test data, we predict on the test data, we convert predictions to a data frame, and then we have a submission file that we use to submit. All right, this is just a snippet of what the submission file would have looked like. It would have had the participant ID, prediction for the outcome of ADHD, and a prediction for the gender of the person. Yeah, and this wraps up my section on feature selection and statistical modeling. This section in itself is a very big topic, and I know that we would have just kind of skimmed through a lot of the topics, but the onus is on you to kind of do some further research on it. But this is just more to prepare you for the WiDS Datathon. All right, so if you guys don't have any questions, I'm guessing we can take the break now and then we can start back with the data storytelling section.
Yes, so thank you so much, Julie. That was really, really very, very comprehensive. And I know if you all have any questions, I'm thankful that you all haven't asked any questions. If you have any other questions, feel free to let us know, right? So shall we take a probably a 5 minute break, 5, 6 minutes, so until probably 12:15. Is that okay for you all? Right? So we'll take a 5 minute break, and then we will resume with the data story section at 12:15. And the data story section, Melanie and Leslie Ann will go through with you all, showing you all how to pull together what Julie said there into a storytelling aspect for reporting purposes. So we'll be back at 12:15. Well, 12:15 AST, right? 5 minutes break. Okay, great. So 5 minutes have passed. Let's jump back in. So I'll pass it back to Melanie and Leslie Ann for the next section.
Thanks, Dr. Addison. Leslie would be presenting the first part of the story data telling, and then I would be presenting the second part. So, Leslie Ann, on to you.
Thanks, Melanie. So hello, everyone. Hi again. I'm just going to share my screen now. Let me know if it's visible.
Yes.
Okay. So, present. Right. Thanks very much. So, in my so we're going to be starting with the crafting compelling data storytelling section, and I'm very happy to be here with you. I forgot to mention in my introduction that I'm also a member of TT Lab. They do data science research, so they're often required to present papers. So I mention this because this is one skill that I've applied to every job I've ever had, and that's the need for presentations. And the key to good presentations is really your ability to tell stories. Storytelling is a part of who we are as, especially in the Caribbean, whether it's folklore or like family tales, how we explain things in everyday life, we can naturally craft stories, engaging stories. But what if we could do the same with data? Because after all the hard work of analyzing your data and building data models, what's the use of those insights if it doesn't reach the people who need to use them? So the stakeholders, the decision makers, or even the public, our stories can drive action. With that in mind, let's explore. What is data storytelling? Data storytelling is the art of combining data, visuals, and narrative techniques to communicate insights in a way that is engaging, understandable, and actionable. So it bridges the gap between complex analysis and audience understanding, making data-driven insights relatable and more memorable. So think about how major companies like Google use data storytelling to drive decisions on their Think with Google platform. Just wanted to show you a little bit of that. Can you see that? This is the Think with Google platform. They share stories through, they share data and findings through these stories, and they make them really engaging. You really want to check out what these stories are about. Even WiDS use data storytelling to drive the decisions, and also see how they're doing meeting their goals with their data science salary report, for example. Or take Spotify Wrapped. I think this is fairly popular. Most people know how it works. At the end of the year, it takes your raw listening data and tailor makes a personalized story. And people really look forward to it because it helps users see themselves in the data while reinforcing why they love the platform. It's kind of brilliant. And this is an example of a data story is really driving action, change, and trends. It's a driving business in this case. So with that, coming back to our presentation. What is the power really of storytelling? It's what makes it so powerful. It simplifies that complex information, like we said, influences decision making with actionable insights, and engages a broader audience beyond the technical experts. And it highlights key points effectively. Companies like Netflix use data storytelling to inform multi-million-dollar decisions. For example, I don't know if anyone remembers, in 2018, Netflix would have paid $30 million for the rights to streaming that show Friends. Maybe everybody knows it. A year later, after analyzing viewership data, they realized its immense value. And when they had to fight to keep the rights against other streaming services, they happily paid not happily, paid $100 million to keep it for the following year. So that's an example of data storytelling driving business strategy again. And for more examples, you have a whole research website on that Netflix publishes to learn about their analytics, how they use computer vision, all really interesting stuff. So feel free to check it out. The links should be in this slide, or we can make the links available, but it's really easy to find, just Netflix research. And going back to the presentation now. So I want to talk about the 3 core elements of data storytelling. And that's data, visuals, and narrative. The data ensures credibility and supports the narrative. By using reliable sources, we can enhance trust of our viewers, of our audience. The visuals help the audience grasp insights faster than using charts, by using charts, graphs, and infographics. And the narrative connects that data and visuals into a structured, meaningful story. If you want to look at this Venn diagram here, for me, this is very useful. So when you build a narrative to help your audience understand complex information, your narrative should help you explain insights from the data and the context surrounding it. You should use summary data to support your objective. Use your visuals to enlighten the audience, to clarify key points, and uncover hidden insights gleaned from the data. To connect, you should connect your visuals within that narrative to engage your audience, to entertain them then, and make it memorable. The right balance of narrative with the right data and the right visuals makes for a data story that can inspire change. So let's practice one way of crafting a strong narrative, and that is the narrative hook. If you took any English classes, it's pretty straightforward. A narrative hook is a hook is a narrative device that serves as an intro to a data story that can grab the audience's attention and just draw them in straight from the get-go. So let's say we want to convey our findings from the datathon to 3 separate audiences. So we see here we have some government officials deciding on healthcare funding, data science enthusiasts, and the general public and advocacy groups. Here are 3 hooks. I'd like you to match them to the appropriate audience. So I'll just read them for you really quickly, and then you can have about a minute to go over it. 1, every year, thousands of girls struggle in school and the workforce because their ADHD goes undiagnosed. This isn't just a health issue, it's an economic and social challenge. 2, meet Widsy. She's bright, but struggles to focus, gets anxious about deadlines, and often feels overwhelmed. Teachers call her scatterbrained, but never consider ADHD because she doesn't act hyper. 3, can a machine learn to recognize ADHD better than a human? What if an algorithm could spot the subtle brain differences that doctors miss? So I'd like you to choose between those, put them in the order that you see the groups in. So if you think the hooks that go with government officials, data scientists, and the general public in that order are 1, 2, 3, I'd like you to type 1, 2, 3 in the chat now. I'll give you about 30 seconds to read them again and put your answer, starting now. Okay, thanks very much. Thanks for everybody for answering. I see a lot of correct answers. Let's check it out. So I think the best data story hook for each of these audiences are as follows. First, we have this one, and I put some terms in bold. Just check those out really quickly, and maybe you can guess why I chose this one. So this one talks about school, the workforce, and health issues, economic and social challenge. So those words like point to how this hook is policy focused, and it highlights economic and social impact and provides a data-driven basis for financial funding decisions. Next, for the data science enthusiasts, I chose this one. Can a machine learn to recognize ADHD better than a human? Because it emphasizes machine learning, maybe, and talks about algorithms. So it really focuses on that audience that it's appealing to. And for the public group, I chose this one, which really it humanizes the topic. It makes it relatable, and by using a relatable and personal story to make understanding ADHD more accessible, this can appeal to members of the public that don't have much technical background but want to learn more about the condition. So moving on. Here are some nice steps put together for you to bring your data to life. First of all, we want to define the problem. What question are you answering? In our case, in the data challenge, the challenge question was clearly stated for us. But in situations where we just have a data set and we have to be the ones who are choosing what exactly we're doing, we have to start with a very clear problem definition. So we need to clearly state the objective of your data story as well. And to help you formulate that, it helps to know your audience, step 2. So tailor your story to their expertise and interest, as we did in that activity just now. We don't want to use overly technical terms with a mainly non-technical audience, for example. And say you have a mixed audience of, you're talking to people from the medical field, and your audience may have doctors, a CEO, the policymakers, and investors. Who do you cater to? So my advice is to focus on the decision makers in the audience, as they're the ones who are driving change. Next, you should determine what data really matters to the said audience. You want to be able to find trends and patterns and correlations to answer the problem question that your audience really cares about. So you really have to keep them in mind through all the steps. You should use tools to uncover trends and insights, example, Python, R, and Excel. Melanie will talk some more about those tools you can use to clean and pre-process data and identify those trends and patterns that we discussed in workshop 1, and to use statistical models to validate insights that you would have just seen presented by Julie. So next, you want to design clear visuals, choose effective charts, and avoid clutter. We produce a lot of charts throughout your analysis, but if we present too many of those, they'll be confusing and we'll lose the real message, the main message in our presentation. So you want to really decide what it is that you want to get across, what is the main insight, and ensure that it's clear and direct, and keep it simple to avoid overwhelming your audience. Okay, so next you want to be able to craft your narrative and make it structured and engaging. So in this section of crafting your narrative, your data story, much like when you were in maybe primary school or high school, when you're writing a story, they say make sure it has a beginning, middle, and an end at the very least. Because at the beginning, in a data story, we want to set the context. So example, why is ADHD in women under-researched? We should have a middle where we present our key findings from data analysis, and an end to conclude with the insights and the recommendations. So beginning, middle, and end is just maybe one framework, depending, and it works really well for what we're if we want to present the findings of the Datathon challenge. In different settings, so to do with business or bring up awareness in the public, there's different narratives we can use. So another one, if you did any creative writing or that kind of thing in school, you might have remembered something like character, setting, problem, solution. So characters in this situation would be like the stakeholders or the people who are affected by your data study. Setting would mean like what's going on before some change was introduced, i.e. the problem, and then how that was solved. That's one framework. If you look up data storytelling now, I'm pretty sure one of the first frameworks you'll see is the setup, conflict, and resolution, which is pretty much the same. The setup is the characters and the setting, conflict is the problem, and the resolution is the solution. So that's a really nice one to remember, to set up conflict resolution. And that's a good way. It really works well for business because it helps you to like hyper focus on what charts you should really use, because when you're presenting to non-technical people, they really just want what's the takeaway. So that helps you narrow down your choices of what to present. And one more I wanted to present because I thought it was a nice framework. The what, so what, and now what framework. The what lets you talk about what's going on, what's the problem. The so what section lets you talk about why it's important. And the now what section talks about what we can do to change or what actions we can take. I think that's a really nice framework for if you're trying to bring awareness to a certain topic using data. So overall, for crafting your narrative, you should build a story around the data that's easy to comprehend and keeping it simple, again, to avoid overwhelming your audience. And use relatable examples so that people can see themselves in the data and want to hear what are your findings. So step 7 is to get feedback to be able to refine and present your story. So in refining, you want to polish your story and make sure that it's presented in an engaging manner. So to begin this presentation, refining and presenting, after putting together your nice narrative, you might say, well, now I need a snappy title to top it all off. So once again, we'd like to put something that would get this viewers or the listeners' attention right away. So once again, we have the same 3 groups: government officials, data science enthusiasts, and the general public. And we'd like to make it snappy. Choose the best title for each for our data story based on the audience. In the same way, please type the order of the numbers of the titles that we have here. I'll read it really quickly. 1, why ADHD in girls goes unnoticed. 2, transforming education and workforce equity, leveraging AI solutions for ADHD in girls. 3, how AI is transforming ADHD diagnosis. Okay, please type your answers in the chat now. 30 seconds on the clock. Okay, thanks everyone. I think I see some good answers there. So I'd like to show you what my answers are. And if you disagree with them, feel free to let us know in the chat. So for government officials deciding on healthcare funding, I thought 2 was a great idea because, what do you think? Why did you choose 2, for those of you who choose 2? As with the narrative hook, it's policy-oriented, focuses on workforce impact, education, things we really care about. Plus, you mentioned AI to make it you know, attractive. It's a buzzword, but we put that after. We put the words that they care about higher up: education and workforce equity. Next, for data science enthusiasts, I put how AI is transforming ADHD diagnosis. Transforming AI, we're using AI. Those sound nice too. It's really short, it's succinct, and we put the AI further up, more to the top, because that's what the data scientists will care about. And the general public, I put why ADHD in girls goes unnoticed. And this can appeal to everybody. ADHD is why they came to find out more about that, so it's up there at the top. And one more note about the using this data story involving a character like WiDS, like in the previous example. I put it for the general public, but really you can use that for any audience where you want to humanize your data and make it more relatable and just really help the audience to focus on why you're doing these studies, who is it hoping to help, rather than talking strictly about data. So now that we know how to structure a great data story, how do we put it all together? To take us through the next steps, I'll hand it over to Malini, unless you have any questions for me.
Okay, thank you, Leslie Ann. So I will just go ahead and share my screen. Please let me know if you're seeing my screen, the presentation.
Yes, we are.
Okay, great. So just continuing from what Leslie Ann have been presenting, now we would look at some tools for data storytelling. These tools will help you transform raw data into compelling data stories through data analysis, visualization, and engaging presentation through certain platforms to drive insights and decision making. For data analysis, in this workshop, we have been using Python, which we can see is a powerful programming language. There's also R, that is more of a statistical computing language. Then we have Excel, which is a tool for basic data analysis. You could use Excel, but you would need a license. So if you don't have a license, you can use Google Sheets, which is free and ideal for collaboration. Under visualization, we have the Python libraries that was used in the workshops, such as Matplotlib and Seaborn, that helps you visualize graphs, such as the histogram graph. For R, we have the R libraries, such as the ggplot2, and this helps us to create graphs. As well as we have the Power BI and Tableau that are used to create interactive dashboards and reports. For storytelling, we have Canva or Google Slides that you can use. Google Slides, this integrates well with your Google Workspace. Also, Microsoft Power BI can be used, but similarly to Excel, you will need a license. So here we have an example of a Power BI dashboard, what it looks like. So this here is a hair loss prediction dashboard that was created by Adir Suchit, a fellow WiDS contributor, and it provides insights into hair loss trends across different age groups, the contributing factors, and treatments. So one good thing about this dashboard, I'm not able to demonstrate that to you because this is just a screenshot, but in this dashboard, what it allows you to do, like if you click on a particular age in the dashboard, all the visualizations will update to reflect data for that age group. So this interactive feature, it really helps analyze age-related patterns in hair loss. So this is just an example of WiDS future initiatives. If you're interested, you can visit our website and subscribe to our newsletter, which can be found on the homepage, to stay up to date on upcoming outreach programs. Now that we have learned what it takes to create a compelling data story, we're going to put all the pieces of the puzzle together using the WiDS 2025 dataset. So before we get started into telling our data story, a short overview before we begin. So the problem that we're trying to solve is how to leverage fMRI data to develop a predictive model for ADHD diagnosis in females. The data that we are using are from credible sources, such as the Healthy Brain Network, the Child Mind Institute, and Reproducible Brain Charts Project. In workshop 1, there were a few visualizations that were created. So when selecting your visualizations, focus on what is important. When presenting the results, tailor your approach to your audience technical level. The results being used can be found in Julie's notebook and presentation that is under the overall performance component. After sharing your findings, make sure you discuss the next steps. The next steps is crucial because it guides future actions, and this ensures insights lead to meaningful impact and continued progress. So today, my audience is you, the participants of this workshop. So here's the title of my presentation. Today, we will be looking at how AI is transforming ADHD diagnosis. So imagine you have a girl named Emma. She struggles to focus, constantly feels restless, and finds it difficult to keep up in school. Her parents and teachers are unsure whether she has ADHD or if it's just a phase. Scientists and medical researchers have long recognized that ADHD symptoms are present in males and females differently, but most ADHD studies have focused on boys. This gap in research means many girls like Emma go undiagnosed or misdiagnosed, and this could affect their education, self-esteem, and mental health. To address this issue, data scientists at WiDS Datathon 2025 analyzed functional MRI data to develop a predictive model for diagnosing ADHD in females. Their goal was to identify unique brain connectivity patterns that differentiate ADHD patterns from neurotypical individuals. Emma's story is just one of many, but to ensure a comprehensive analysis, researchers needed a diverse dataset. So thousands of fMRI scans were gathered from different studies, such as the Healthy Brain Network, the Child Mind Institute, and Reproducible Brain Chart Project, ensuring there was a diverse dataset. This includes participants with and without ADHD, as well as male and female participants. It also included socio-demographic, emotional, parenting data, and functional MRI data. The fMRI data captures the brain activity and connectivity, which can be analyzed to identify patterns associated with ADHD. So leveraging neuroimaging data enhances the ability to detect ADHD more objectively than traditional behavioral assessments. Looking at the demographics is important because it helps ensure that the data is representative, unbiased, and inclusive. Here we can see that 68.5% of participants were diagnosed with ADHD, while 31.5% did not have ADHD. This suggests that the data has a good representation of individuals with ADHD. However, 65.7% of participants were male and 34.3% were female. While the dataset still had a higher number of males, it provides an opportunity to focus on ADHD symptoms in females. When Emma's parents sought a diagnosis, they were often met with doubt. But could their background, such as education level, play a role in whether ADHD is recognized? The data here in this graph shows that ADHD diagnosis rates appear to be higher in certain parental educational levels. We can see ADHD diagnosis is more commonly reported among children whose parents have higher education levels, and that is more like college or graduate degrees. This means parents with higher education levels may have greater awareness of ADHD symptoms and seek diagnosis more often, or they may have better access to healthcare and specialists who could diagnose ADHD. The predictive model achieved 83% accuracy for ADHD diagnosis and 77% accuracy in distinguishing sex-based ADHD patterns, outperforming conventional screening methods. This breakthrough suggests that fMRI data can offer a more objective and accurate way to diagnose ADHD in females than behavioral assessments alone, which often lead to misdiagnosis. These findings underscore the urgent need for gender-tailored diagnostic tools, ensuring that individuals like Emma receive the support they need. Emma's story is far from over, but thanks to this research, the future of ADHD diagnosis could change for girls like her. The next step is to develop a clinical tool that integrates the fMRI-based predictions with traditional ADHD screening. As well as we can combine the neuroimaging with behavioral assessments for a more holistical approach. The goal is to ensure early detection and accurate intervention, helping individuals like Emma thrive in school, work, and life. So this brings us to the end of the storytelling example, and as well as to the end of this presentation. So just to recap, data storytelling transforms raw data, such as numbers and text, into insights by combining data, visuals, and narrative techniques. Data is just a tool, but the real power lies in how we tell its story. Crafting compelling narrative enhances data-driven decision-making. The WiDS Datathon 2025, it provides a unique opportunity to apply storytelling techniques to real-world data. And this is good practice. So this brings us to the end of workshop 2. Are there any questions for this component?
Just out of curiosity, thank you so much, Malini and Leslie Ann. Really, really nice, comprehensive flow and very, very interesting and interactive too. I think everybody would have been given a nice informative view of how to pull together these stories. Anyone in the chat here is interested in participating in a datathon? Out of curiosity? Any of you have any interest in it or just generally want to pick up the knowledge? Yes, I see Marlon says yes. Anyone else? so far? And that's okay if not, because this is really just for general knowledge as well. So if any of you, so thank you. And Marlon, I know you contacted us as well, right? So thank you for that. So if any of you are interested in participating in the Datathon or on our teams, you could get into contact with us. For the rest of you who are here, we really are grateful for your presence today. And I would really like to sincerely thank our speakers, Julie, Leslie, and Melanie, for really putting together a nice, as Nadia said, enlightening session and content for everyone today. Not forgetting the support that we have also had from our other mentors, Priya, Nicholas, and Videsh in the chat. So we really, really want to thank you all for being here. And Michaela telling thanks to this team. They learned a lot. We're really happy to hear that. Don't forget, we have a feedback form for you all. And also the feedback form is important. If you have any other interests in other specific workshops that you would like to see, we can see if we can facilitate that. Just letting you know, based on what Melanie mentioned about the Power BI and Python, we will try to do a workshop on that either in March to April. So stay tuned for that as well. And also for our fireside chat with some of our mentors and some the international speakers in data science as well. We will have that on March 8th. So I think we have come to the end of the session. Thank you all again for joining us and stay tuned for the next one.